me?
Just kidding.
Okay. There you go. You can talk now.
All right. So this is Standalone Cinder. How many people are familiar with what Standalone Cinder is all about? All right. Cool. So then we'll start at the beginning. So the idea that we had was a while back was to take Cinder. How many people know what Cinder is? Okay, good. So I'm not going to...
HDMI.
So the idea was to take Cinder and make it an actual standalone project that you could use without Nova. So for example, some of the earlier demos that we did were things like using Cinder as a plugin for Docker and Docker Swarm, and then followed on to Kubernetes and things like that. The thing that's interesting is we got it stripped down to the point where you can even do it to a point without using Keystone. So you could truly just deploy Cinder as a standalone service, and any backend that you use in OpenStack that's supported and everything else, you could just use that and then plug it into other external projects outside of OpenStack. The use case that came up that was pretty common that seemed to work fairly well for a lot of people early on was taking an OpenStack cloud that they had deployed and everything else, and using that Cinder deployment inside of that cloud for other things to provision storage to. Right? So that was the idea. That's kind of where it went and where it started. Since then, it's kind of evolved a little bit more, and we've done things like we've added what's called no-auth support inside of Cinder. So now you don't need Keystone. You can actually just give a username and a tenant ID, and you can just access Cinder and use it. We've added an extension to the Cinder client that lets you do local attach. So for example, if you have a OpenStack cloud running somewhere, and it's iSCSI or whatever, and you have a network attachment, even if it's Fiber Channel or NFS or whatever, you can now say things like Cinder create a volume and then say Cinder local attach. And it will actually, under the covers, go through all the process and everything else for whatever connector you need and attach it to that machine that you ran that command on. Right? So it's a true standalone thing. And then finally, the last thing that we did with it, quite a while ago now actually, is we containerized the whole thing. Right? So if you go inside of the Cinder GitHub repo, there's a directory called contrib now. And inside of that contrib directory, there's this thing called blockbox. And blockbox includes a make file and some Docker compose files and things like that, to use an example, so that you can actually spin up a standalone Cinder service and consume it and use it right on your laptop. Right? So that's kind of the idea. That's what we have. That's what we've been working on. We're also now working on things like there's a thing called Container Storage Interface, which is a standard API for block storage or for storage in the container world. So we're doing a driver implementation for that. All kinds of things. So the whole idea is to take all of this stuff and all of this work that we've invested over the last 7 or 8 years in Cinder and throw it out there so that people can use it in other places. Right? So that's the history. That's the quick summary.
John, how is that the CSI driver for Standalone Cinder different from the existing one, the CSI plugin for the cloud provider?
Yeah, so if people are familiar with CSI, it's a little confusing because there's a lot going on. There's an existing cloud provider plugin for Cinder in CSI, but it is strictly set up right now to work just in an OpenStack environment. And that is designed specifically for, I'm deploying Kubernetes on top of my OpenStack cloud. Right?
It requires Keystone.
It requires the whole deal. Now, you can actually tweak it right now and do the no-auth thing if you want, but nothing else is going to work. The only thing that's going to work is Cinder. So you got problems. It's not good. But yeah, that's the thing. So it's not standalone. It's a full OpenStack. That's the difference.
When you say it's no-auth, is there any option to connect to other authentication mechanisms?
Yes, there is. I have not personally done it, but the reason we were able to do no-auth is because we did convert everything and switch it to use a plugin model for authorization, which means, in theory, you could write any authorization plugin you wanted and slap it in there.
Driver-based. Right.
Yeah, exactly. So the standard OpenStack model, right? So that's the beauty of OpenStack, right? And the same thing with Cinder is we've got this nice framework and everything else, and you just add whatever drivers you want in.
So why would you want to do this?
Why would you not?
You have users that are saying we have a requirement for this
A requirement?
or desire.
So here's the thing. From my perspective, being at a startup where I was doing plugins and drivers and things for storage, right? So I ran into this really interesting problem when containers started to get really popular, and then there was Swarm, and then there was Mesosphere and DCOS and Kubernetes and all these things going on, right? What I found was, this is crazy. It's stupid. Everybody's going off and reinventing what we did in Cinder. They're writing the exact same models. They're writing the exact same things all over again. And not only are they doing it over again once, they're doing it for every single one of those platforms. So they're doing it like 6 times, right? Which is crazy. The other thing that I found out from a customer perspective, what I found was all these customers that had bought storage and deployed OpenStack and deployed these different things, they were running into situations where they're like, okay, well, now I need an OpenStack expert. I need a Cinder expert. And now I need a Mesosphere storage expert. And now I need a Kubernetes storage expert. And now I need on and on and on, right? It's stupid, right? So rather than go down that path, what we found was it was really interesting to say, hey, I can actually just use one de facto storage abstraction, an API set, and move that around and plug it into all these different things. So take that plugin model that we use down here in OpenStack and bubble it up to other infrastructure or other compute services. Right? So that's where the value comes in. How it works out and how it shakes out in the end, only time will tell. Personally, I think it's a huge value as long as we can keep Cinder at a level where it doesn't become something that's a burden. Right? And right now it's not. I think that right now Cinder is simple enough, and it's definitely robust. It's been around for over 7 years now. It's been tried and true, proven in production in huge deployments. And the nice thing is you get that whole, everybody likes to talk about, how many different vendors they use or whatever. You can pick, there's over 80 backend storage devices that are supported. So it gives you a ton of flexibility, right? So
do we have compatibility for all of the drivers, for all of the types of targeting we want? For example, can we provide all of the drivers that we have for Cinder for Kubernetes or for Swarm?
So yes, with a caveat.
Okay.
So if you're using for the Cinder cloud provider thing, yes, hands down, that just works. Right? If you're using the standalone Cinder and you're going down that path, you can, but right now we're actually trying to work out the best way to solve the attachment problem on the nodes. Right? So in the CSI driver, for example, one of the things that we're hung up on and then we're trying to kind of work through is figuring out how do we want to implement this whole attached connection thing for all these different topologies. One solution that we've proposed that we're looking at right now is taking the Cinder client that we talked about that has that extension that already knows how to do all this stuff, taking that and running that in a container as a sidecar container in Kubernetes or wherever, and saying, hey, anytime you want to do attach, what we're going to do is we're going to take all that information, we're just going to pass it over to this little container over here that's running this client extension and let it do it locally, and you're done. That works okay. There are cases where it's not such a great idea.
But as a general, you're talking about specific case, but as a general mindset, do you think you're thinking about we'll be able to create drivers for each type of provider that we need to write to? We have a driver for Kubernetes, we have a driver for Nova.
So let me back up. So that's something that's really important. I mentioned this CSI thing, this container storage interface. The whole premise behind that is to have one single driver, one single interface that works across. Yep, exactly. So that would solve that problem. right? There's some implementation details, which is what I was starting to get into, and how you do the attach. Because the thing about Cinder is it's not just iSCSI, it's not just Ceph RBD, it's not just NFS. It's fiber channel, it's all these different topologies, right? So that's the hard part. That's the hard thing to solve. So yeah, that's where we're going.
So will the containerized version of Cinder scale to production, or is that just for?
Absolutely. And in fact, the way I wrote that is it's actually using the Loki container project in OpenStack, which people are using in production to deploy large-scale OpenStack clouds, right? So all I did was I just picked out the Cinder pieces. So it's also really cool because when you run that make file that I have in there, it's actually just going and pulling the bits out of the GitHub repo and running them right there and building it. Right? So you're building it dynamically. So yes, absolutely. And in fact, I would argue that this model and running it in containers actually scales better than running it on physical machines.
Is that in terms of Kubernetes? Like, how does that work like across namespaces and nodes and things like that? Is it just run as a system account?
So yes, you set that up as part of a system, and the CSI driver is actually where all those implementation details end up taking place. It's actually not so much the CSI driver; it's a CSI implementation in Kubernetes matched with a CSI deployment model for Kubernetes, right? So you mesh those two together.
So if containers looking for storage, it goes to CSI, and CSI goes to the Cinder container to attach it.
Pretty much. That's pretty much. So the way the CSI architecture works is basically you set up your PV with the you have a CSI driver or a plugin running that has a name for that endpoint, and then your PV, when you have the PV spec written up, you tell it which one of those endpoints you actually want to point to. So, and Shanna can correct me if I'm wrong, because she's the other CSI/containers expert. So, thoughts, ideas? Does this sound like something interesting to anybody?
Yeah.
Does it support all the features, including the encryption?
So,
Because we need Barbican.
which piece?
The standalone.
So, it will include that if you add Barbican, right? So the thing that's cool about this is it's a true pluggable model, right? So, standalone Cinder can mean a lot of different things. Standalone Cinder can just mean standalone without Nova, or it can mean standalone in terms of, hey, it's just Cinder and nothing else. So if you run just Cinder and nothing else, you're not going to have things like encryption with Barbican and stuff like that. And you're not going to have some of these other nice things on top of it, right? But maybe you don't need those things. Maybe you do. Depends. Right? So you kind of get to pick and build. It's like a buffet instead of a meal.
John, if you kind of comment, so I'm looking at kind of two level things. So one is, okay, I would like to use Cinder so I can put my volumes, basically set up the OpenStack. So I have something, basically I have a bare infrastructure, I still need some volumes so I can put my machines in whatever mode I wanted to do. Maybe for OpenStack, maybe for Kubernetes, maybe for whatever else. Okay. Then after that, in each of those separate areas, let's say there's stack deployment on some of the nodes, there is purely bare metal, where there's no anything else, but they still need volumes so they should be running there. Not attaching to any VMs, but basically that is node. Or Kubernetes, whatever variety, OpenShift, it doesn't really matter,
Sure.
which do need to attach the volumes to specific things. So how do I kind of do it on those? How do I manage?
One Cinder deployment for all those things?
Well, either manage it or separate them in two ways so they don't clash with each other.
So separating them is really easy, right? So all you're doing is setting up different endpoints. So each one is its own unique endpoint. So you can have multiple of these standalone things. That's easy, right? That's something that we've always been able to do.
Well, except that now you require the data plane to be crossover. Because they're going
Only
to
on the
same-
ones that you want to communicate with.
Well,
Right?
if they're all going to the same backend storage options, which we are supporting in Cinder, then different pieces.
Oh, so what you're saying is if I wanted to have one single backend storage device and have multiple cinders all deployed and talking to that one thing. So that's doable. I have a lot of customers that do that. I do that. But the thing that I will say for that is make sure you choose the right storage device. Because what you need to do that, there's two problems. One you touched on is now all of them have to have access to the control plane, right? That's the first problem. The other thing is the tenancy problem, right? So some devices have the ability to do things like describe unique VLAN endpoints for different tenants on the storage device. So SolidFire, for example. So for me, it's easy, right? Because that's my product has that, so I was able to implement that. There are other projects in OpenStack storage devices that allow that as well. So you have to be careful. If that's the kind of model you want, you just have to be careful that the product will actually provide the capability to do it. But that's a common problem with abstractions in general, is figuring out what I can actually build on top of the actual base platform to make my abstraction work the way I want it to.
Yeah, it's more security because if for the ironic under the covers, I need to have the volumes which I can pull from.
Yep.
And obviously, I don't want any of them invisible to any of the tenants,
Right.
irrespective of the platform you're going to upload. But okay, I prefer to use the same shared storage for all of
Across
them,
all
so
of it.
me creating multiple ones.
So as long as you have a device that supports multi-tenancy, you can do that. And then if you really want to be secure and isolate the control plane and stuff like that, then you need to go to that next level and find a device that not only has the multi-tenancy, but also allows you to set up specific VLAN endpoints for each one to segregate. And that's something that's possible. And these are the reasons why, in Cinder, we've been doing this for a really long time, right? We've been doing this for 7 or 8 years now. And the thing is while all this is going on, I'm watching all these other projects sprouting up out in the wild that are doing storage abstractions just like Cinder, right? And I'm like, well, all right, I'll join in, So make this a standalone thing and use something that actually already works and already has the experience, right? So, yeah. I feel like I'm trying to sell you a car. Does anybody have any? Oh,
So does this have full parity with non-standalone Cinder?
it's the exact same bits. It's the exact same API. The place where the parity, where it does not have parity, are where you start to interact with other external services, right? So things like that, as was mentioned, Barbican with encryption, it's not going to work. Right? You can't do that. Anything that required something on the Nova side, obviously you're not going to have a Nova, so that's not going to work. Things like that, right? Some of the backup stuff, obviously, is not going to work because there's Manila options for backup. There's Swift options for backup. So obviously, if you're running this by itself, those aren't going to be available. But in terms of how everything works, it works exactly the same way. There's no difference.
Right, so if you are hypothetically writing a Cinder driver, you just set up standalone Cinder and do all your testing.
So for the last 2 years, I rarely have deployed a full DevStack deployment for any of the code that I've worked on in Cinder. For the last 2 years, almost everything that I've been doing has been in containers on my laptop. And I was using this for a really long time, and I was like, hey, this actually is pretty cool. It works pretty good. Why don't I just push this out there? And then I got help from folks like Yvonne and some other folks to make the no-auth stuff work. And then it was like slam dunk. I was like, oh, this is great. So.
Or the different behaviors from block-based storage as well other than share-based, file system-based storage? Anything interesting that one should consider?
Yeah.
Yeah, I mean that is a follow-up. Yes.
Yeah. So OpenStack is the nice thing is they've got this really cool project for shared file services called Manila.
Yeah, of course.
So if you want to do shared file systems, use Manila, hands down.
No, I mean for from the how Cinder behaves when it's standalone. Were there any specific problems or anything that one should consider when using file system versus blocks?
Yes.
So honestly, for now, we don't support NFS-based driver in standalone mode, mostly because multi-tenancy issues.
Mm-hmm.
So if you need NFS-based storage for Cinder in standalone and you don't care for multi-tenancy, because there are a lot of private clouds that trusted one tenant, you can easy to add NFS support. I can share you a link with my page for this. But it's easy to implement this in standalone with Keystone with multi-tenancy because we have to start some internal VM to create NFS share per tenant because current drivers creates volume for all tenants in one share. It's not secure to share it.
That's in the no auth model.
Yeah, and not only no auth. We don't support NFS standalone. That's why.
So is it then official? Is we do not support this?
For now.
Yes.
Unless you want to do an auth plugin
Yeah.
to your liking and everything else to get the tenancy back, right? So that's the thing. There are little weird cases where if there's anything about what you're trying to do that relies on or depends on another OpenStack project, obviously when you run this by itself, you're not going to have that. Right? It's not going to.
So my remark on the aggregate would be that for Manila will support Cinder, and there's no reason you can't make a standalone Manila for shared storage.
Or Manila on top of the Cinder volume and go.
Yeah.
No, I mean whether or not it's on top of the Cinder volume.
Right.
I'm just saying if what you want is shares and standalone. So for example, if you wanted to run Cinder and Manila standalone to supply storage to Kubernetes, for example, Manila can run off. Manila can run therefore without Keystone if that's what you want to do. Really, in other words, this is in the fine tradition of Manila stealing from Cinder. I don't see it. And you end up with a kind of storage that can be easily shared among multiple hosts with multiple writers. And there's a place for that. There's also a place for fast raw, block access and so on. So I see it as a little complementary.
So what do I have to do to get you guys to try it? What do I have to do to get you to drive this car home today?
Unlimited car washes.
No payments for the first 3 months. No support either.
Free solid fire.
Yeah.
Throw in a free solid card.
I'll throw in a free net app.
Some stickers.
And some stickers. Lots of stickers. So, no, in all seriousness, though, the whole idea behind this is truly to be a vendor-agnostic, standalone thing that just works. And that has been the philosophy of Cinder all along. And we've, as a community, we've done a really good job of keeping that. Right? So we've been pretty good about that. And this is no different.
I'm curious, have you played with Cinder Backup in this context?
I haven't even tried it because
I got this dim memory of a few years ago, thinking about Cinder Backup with you, in fact, and among others, and us thinking of one of the efforts was to decouple the backup and volume services so that one could
Run it as an extra
potentially elastically run backup services on demand. And I think both of us remarked at the time that seemed like a better fit for Kubernetes, for example, than OpenStack in terms of, OpenStack could maybe do something like that with Magnum or something like that, but that it was kind of a natural workflow for a Kubernetes-driven. Basically you don't want to tie up resources all the time for backups that run occasionally, and you want to be able to handle bursts.
And you started that, splitting that off.
Yeah, but we never
Finished it?
We never took it to any kind of elastic control of that stuff.
So,
Probably because my employer wasn't interested.
Right. So the funny. The thing that's interesting about all this, I was actually one of the people that started the Cinder project. And when we first started it, we had this idea and this concept that we wanted it to actually be a standalone independent thing, right? It just took us 7 years to get there, right? So Swift was really smart, and they started off and they just said, we're a thing, we're a standalone thing, you can use us for whatever, and you can plug us in, right? We should have probably followed that model a little bit more. I think it would have been better, but
But right now it's already a standalone. It's a service by itself now. It's already not together with the volume service. So you should still be able to use that in this.
you should
setup.
be able to go ahead and launch the. So I'm not building in Blockbox.
Yeah.
I am not building or deploying the backup service.
Right.
Now, that being said, you could probably just go ahead and take that Docker Compose file and modify it and add the backup service to it really easily. And by the way, for those that don't like Compose, we are working on Helm charts.
So the idea is that every time that you need to back up something, you create a container and then shut it down.
You could.
That's
the
my
beauty,
idea
right?
For how you would do it.
That's the beauty, is you don't have to have it running all the time. You can actually just launch it and run your backups and then kill it.
Can you have the same thing on volumes, on single volumes?
No. And the reason why is because of the database. We are database crazy in OpenStack, right? So we like to put everything in a database. If everything was ephemeral and there was no persistence, sure. And you can do that, it'll work, but there's a lot of things that you're going to expect to work that aren't going to work right. So the database thing is easy to solve. You create a persistent file, and you store it, and blah, and so when it spins up, it just reloads the database. You could certainly do that and make it work. The reality is, a lot of people talk about that, and they like to see containers going away and disappearing and reappearing. And the reality is, how much value is there really in doing that, right? So when it comes to like Cinder as a service, for example, there's really not that much value because it's not like you're taxing the system and taking up a bunch of resources.
So you're saying that the service is really thin and you don't need.
Yeah, it's not. I mean, you could go that route, but then you're always going to have the API service running, right? Because it has to accept requests, and then you have to figure out, how do I get the API service to trigger RabbitMQ, the manager, and all these other pieces? It just doesn't seem worth it.
Backup's different. This is essentially a data plane service, whereas the rest of Cinder.
Well, and the other thing is with backups, you look at backups depending on how you do it. If you do things like, you have a scheduled backup job, part of the thing that your backup scheduler can do is launch the service, right? So it's a little different. I feel like I'm doing all the talking. Any other questions? Thoughts?
Clarify the CSI effort right now at the moment. So is the standalone the focus of the back end for the CSI Cinder?
So that's my part-time job. So CSI is a broader initiative from the CNCF. So it is an overall far-reaching thing, right? So I'm involved in a number of projects, and one of the things that I'm doing on one of my side jobs is to do this standalone Cinder CSI implementation. Is that, I don't know if that answers your question.
I was kind of curious what the focus of, and we're involved in some of the Cinder activity too.
Okay.
I just was curious what the focus of the drive was.
Yeah. So the CSI stuff is more about, hey, how do we solve this vast proliferation of storage APIs, right? In interfaces. How do we just get the one common one? Which brings me to my next side project, which is a new interface built directly into Cinder just to do CSI. So then you have one plugin and one driver that does Kubernetes, Mesosphere, Swarm, Docker, and whatever the future is, and OpenStack. That's my dream.
Good.
So what kind of marketing, project identity stuff is planned? Are you really going to push for Cinder as its own entity? Is that sort of how it works?
We're going to start walking horses through the summits.
0. That's a 0. I'd be all for it. That'd be great, but I don't know how to do that stuff.
Neither do I.
I'm not a marketing guy.
Trying to sell us cars.
Yeah. So I'm trying to move to sales, and then I'll move to marketing. No, I haven't really done anything. So thus far, all I've done is I've written a few blogs. I tried to give a keynote in Boston last year.
It was awesome.
Darn it. But yeah, that's about it. I do think that once a CSI implementation of this is out, and then once the other container orchestration platforms and stuff like that have a CSI implementation of their own, then I think it's actually going to be pretty interesting to talk about and show, and I think it's going to be really easy for people to see the value.
So Gorka's not here, and I can't impersonate him. But the question would be here, you started an interesting evolution of cutting out more and more parts of requirements from OpenStack. How about...
I know where you're going. You don't want to go there.
Get rid of RabbitMQ and MySQL and just wrap up the drivers with a library and put a little save the model update information and etcd or something.
So just so everybody knows, this is a fraud. So it's a leading question because this is an effort that's actually in progress.
I'm just curious what your take on that.
You weren't in that discussion. What was your thought on it?
I was there and I just remained silent.
Okay.
I'm just curious. It's a similar initiative.
It's actually very different. It's very different. So there's two thoughts on this.
Well,
right?
it's leaner and meaner.
It's mean, that's for sure. For those who don't know, Gorka is like a super brilliant, smart. Everybody thinks he's an AI. But
he does exist.
But he does actually exist in person, or at least his AI created a bot. Anyway, so he's actually going on a different approach, which is really interesting, and I've looked at and worked on a little bit of basically stripping everything out of Cinder except for the actual driver code itself, and then just using the driver code, right? Which is a really interesting idea. And at first I was like, oh, this is really cool. And I started playing with it. And then I realized I was like, but now I'm building all kinds of framework and skeleton and everything else around this to replace all of those pieces that we pulled out, right? Which is really, it's kind of hard. And the other thing that's kind of challenging about that is, keep in mind, right now with Cinder, every time a commit goes into Cinder, there are 80 different CIs, continuous integration test systems, that get triggered and launched. Some of them run, some of them don't. That's a whole nother story. But the reality is there is somebody watching that, or supposed to be, and maintaining it and keeping an eye out for problems and bugs and stuff like that. So what that means is that's the environment that we actually tested. That's the environment that everybody's developing the plugin in. That's the environment that everybody's testing, everything else. So in my mind, to get the real value of the global homogeneous collection of plugins, it's best to kind of do that in an environment where you're actually testing it, right? I would argue that things like RabbitMQ and MySQL are not that heavyweight, but at least MySQL, you could argue that it is, except for when you talk about its Cinder. So it's not that big a deal. I mean, I don't know why, but there's no love for persistence anymore, right? Everybody hates persistence. But then you don't need Cinder. so there's no point in having this conversation. So I don't know how that's going to shake out. I know there's some other reasons why he likes that model, or what, and I shouldn't say he. There's other reasons why people like that model and want to do that model.
I'm curious, like the CSI interface versus the Cinder API, like how semantically different are they?
Way different. So, first of all, the CSI interface is in my opinion, what Cinder should still be. It's basically 5 commands, and that's it.
So it's very much like the volume.
It's very much like what Cinder was the first 2 years, right? So it's create, delete, list, snapshot is now in there, and attach. That's basically it. And get capabilities. Right? Took us 4 years to get that. But that's basically it. So my point.
A volume concept, I guess is what I meant.
Yes, sorry.
The concept of a volume. That was a bit.
You can actually do a one-to-one mapping, and if you look in my GitHub, there's actually a repo where I started to do that.
Okay.
So the nice thing about gRPC, by the way, that people forget is it's not just for Golang. You can do a gRPC server in Python too. So
I'm just curious if it's so different as one thread in that way. It sounds like it's so similar that you're losing a lot.
the answer is it depends. It depends on your use case.
Okay.
So the thing that I'm getting at, so if you look today, and this is like completely tangential to this talk, but I find it interesting. And since I'm the one standing up here, I get to.
Yeah. So you only have 1 minute left.
So the thing with CSI and Cinder, right? The way it works today, whether it's standalone or whatever, doesn't matter. There's this, what I call the middle layer, is this SDK called Gopher Cloud, which is a Golang library to talk to OpenStack, right? In OpenStack services. The thing that's interesting to me is so what you end up doing with a CSI system, a CSI plugin, is you throw up this server that runs this gRPC server, that's the CSI plugin, and then it talks to Gopher Cloud, and then it goes to Cinder.
Oh, now I see what you mean.
And so my thing is hey, knock those two out, put the gRPC server directly in Cinder as an optional server or service, and just run it.
It is just an API.
Exactly. Yeah.
Now I see what you mean.
Yeah. Now, the other thing is, and maybe this is what you thought I meant before, was actually modifying Cinder or doing a fork of Cinder to do just a CSI implementation of it. That's actually something that's really interesting to me for a whole different list of reasons, but nothing that anybody would ever think is valuable except me. So I would like to see Cinder be a simple, small project again, but that's never going to happen. So.
Well, the sprawl has slowed at least.
Absolutely. I mean, we're at a point now. Cinder's at a point now where it's not everybody coming up with any crazy idea they can think of to look smart. They're actually adding things that are needed and fixing things, and it's in a really good place.
Yeah.
So.
As OpenStack projects go, it's probably like the smallest pain point from my perspective. So I don't think about what
I love hearing that. That is the best compliment you could give the Cinder team ever.
Yay!
Thank you.
I don't even think about it.
Perfect.
You still
Stop by our
use
meeting
the
sometime
Cinder
and share
scale.
that.
I love to.
Absolutely.
It's not just in there. You're using it. So you're having a
That's
mini backend to one service.
Yeah, and that's the other argument I have against the other approach.
Right.
Is it loses the biggest benefit that Cinder gives you today is the ability to seamlessly plug in multiple back-end devices. And your user doesn't know about them, doesn't know anything about them. He or she doesn't even know they exist. And the scheduler figures it all out and does all the placement based on whatever requirements.
Lets you plug all the things into all the other things.
Yeah, exactly. But if you go that other route, you don't have that anymore.
You run one-to-one with a storage class or something like that.
But what I'm doing right now is...
And you get to avoid the whole problem of Nova telling you to use a placement service instead of the schedulers. I'm just doing PR for the other...
Yeah, I don't know. I'm staying out of that.
Yeah.
All right.
Quick question. Talking about off-cloud, any plans about implementation of this brick in Golang? I know there is a...
Did you see my email on that?
Huh?
So I sent an email on that
I missed it.
a while back. So I may not have sent it to OpenStack.
There is an empty repository. It's all.
Yeah, so I think that's a good idea. I think that's what we have to do. I've been playing. The problem is I love Golang and I think it's fantastic. The problem is when you're coming from an OpenStack context with Python and you're trying to convert things to Golang, it sucks. It's terrible because you don't have the inheritance model.
Exactly.
And we overuse inheritance in OpenStack like crazy, right? Yep. So when you try and do a brick implementation in Golang, for example, I've got an email that I sent out. I'll find it and send it to you, where I tried out 6 different ways to fake inheritance in Golang, right? And every one of them sucked.
It's just the code sharing that's hard.
Huh?
Which bit of the inheritance is hard? Is it just the code sharing?
Yeah. So Golang doesn't do inheritance.
No.
Right?
It's got the interface ugly kind of.
Right.
Yeah.
So then you get into the thing of doing an interface and write an implementation for all of them. But then by the time you do that with something like Brick, what you find out is you've duplicated 80% of your code that you didn't need to.
You can sort of mark inheritance in Golang by using composition.
So I tried that. And the
It works pretty well.
It does. It works really well. But here's my concern. So this has been my mantra and my beef in OpenStack since I started, is just because somebody can figure out how to do something clever that works really well doesn't mean it's a good idea, because if you want this to be an open source community-based thing that anybody can come in and contribute and add to.
Composition's probably better though. I think
Composition's
probably better.
That's my view. But yeah.
So maybe I'm not understanding what you think, because so if you do the composition, that's fine, but you still have to duplicate all of the.
No. So if you have object foo, which has a bunch of methods attached to it, and then you derive bar from foo, so you have an instance of foo inside bar, right? Then you can say bar.foo method, and it's all just there. You don't have to re-implement.
Right, but then I have to actually instantiate bar instead of foo, right? So I can't.
Right.
So
okay, but if you have an
which
interface,
might be okay.
But if you have an interface, then it's still fine.
Yeah, I have to look at it.
The thing that's always annoyed me is the boilerplate information. It's a shame that there isn't.
A library for it?
Well, so the multiple inheritance in Python is almost like composition. Like almost.
Yeah, actually, I suppose that's true.
It's closer to it's closer to composition than it is inheritance.
Yeah, that's fair. Yeah. I hate inheritance. Yeah. I think inheritance is the worst thing ever invented in computer science.
I mean, this goes distribution principle.
I think objects suck too. So, I started out in C, and now I'm back to now I'm on Golang, and I'm as happy as can be. I will never do C++ again if I can avoid it.
Just re-implement Cinder in assembly. It's no object.
Thank you, John.
Sure.
This was interesting. So, thanks,
Well,
everybody.
hopefully it was at least entertaining.
It was.
And if anybody wants to buy